Hello, this is Dr. Scott Dennstaedt, founder of EZWxBrief, your best online source for aviation weather and education. Welcome to episode 11 of EZWxChat, a program to discuss topics related to aviation weather. In this episode, I'm going to cover the basics of the advisories that are issued by the Aviation Weather Center for convection. We're going to focus on the convective element today because we do have a lot of convection all over the eastern half of the U.S. And it's a good idea to go through as a gentle reminder about how these particular advisories are issued. Now, first of all, I want to discuss a few things, a few different points that have come up over the last couple of weeks. When you are bringing up EZWxBrief, you should try to install it as a progressive web app. I know that's unfamiliar to many pilots or many people in general, but there are many companies like Twitter and Lyft and Starbucks that also use this concept. And so you have to actually install this. It's actually easier than even interfacing with Apple to do that. And the best way to learn about how to install it is to go to the Pilot's Guide. And so if you go to the Start button, and you'll see View Pilot's Guide here. If you click on that, it will bring up a PDF that you can download and read through it. And near the top of the Pilot's Guide, you're going to see every single kind of device, Android, Windows, Mac, all the portable devices, iPad, iPhone, of how to install the progressive web application because it's optimized to run in that environment. And so you notice on here, there are no browser back or forward buttons, no address bar. Essentially, we allow this to happen because it looks and feels just like a native app will without having to necessarily interface with the App Store or Google Play Store. So you can install this on your iPad or iPhone using Safari, or if it's on the Mac, you actually have to use Chrome, or you can use Firefox on Android devices or even on your Windows 10 device. Could be a desktop, could be a laptop. Essentially, you can create a progressive web app from that, and it'll create an icon where you can double click or double tap on that or tap on that particular icon, and it should bring up the EZWxBrief application every single time. So that's one item I want to mention. The other one I want to mention too is that when we're looking at various different elements on the map, if we want to look at the most recent stuff, that is the observational data. Let's go ahead and select flight category and all here. I want you to understand that in order to see the METAR or observations, you need to actually have the departure advisor all the way over to the far left. When it's over to the far left, it's going to show the latest observational data. So you can see here, this is out of Kansas City. It's a surface observation. It says right here at the top. And it provides you with the full METAR that's shown here, plus it decodes it for you above it. As soon as you move the departure advisor to the right by one click, now we're not seeing observational data, we're actually seeing forecast. This is the EZ forecast for Kansas City at this particular point in time. Very far left gets you all observational data, and also will get you information. For instance, in here we're showing a center weather advisory for thunderstorms, and that's only valid through 20Z. So essentially it's showing here because we have a valid time of 20Z showing up here. Essentially the departure advisor always starts at the next top of the next hour, and so since this is valid through 20Z, it's actually going to show that particular center weather advisory. If I move this to the right, you see it disappears because now it's no longer valid. The same will be true of the SIGMETs. So you add those SIGMETs, for instance. Let's go ahead and add the SIGMETs to this. So we have all SIGMETs showing there. Now what we see here is, in this particular case, we have the SIGMETs showing up here, international SIGMETs as well as convective SIGMETs. Now I'm going to go ahead and refresh my screen just so to make sure that it is having the latest and greatest stuff that's going on. And this will refresh the screen with the latest information. All right, so we have all the latest information here. So now you notice also when we're looking at the data here with the departure advisor all the way to the far left, you'll notice that any of these advisories that we see, whether it would be SIGMETs, GEARMETs, center weather advisories, convective outlooks, whatever the case may be, will only be displayed if it actually is valid at the time that you have set on the departure advisor. So here's a convective SIGMET, and we'll look at these a little more carefully. This is valid from 1855 Zulu all the way through 2055 Zulu, and so since I have this to 20Z, it's going to show that. Now if I slip this to 21Z, you notice all those disappear, because at that point in time those SIGMETs will no longer be valid. Now you also see some other SIGMETs down here. These are all international SIGMETs, and you'll see that those international SIGMETs, you can turn those on or off by the setting shown here. And these international SIGMETs are usually valid for a lot longer of a time. In this case 1816 all the way through 2216Z. Usually it's about a 4-hour period. So in those cases those will stay on. Now if I continue to move this to the right time, you'll notice that those eventually do disappear, because once again we're outside the valid time of that SIGMET. The other thing you'll notice here is these yellow polygons, and those are convective outlooks issued by the Aviation Weather Center. And we'll talk about those as well, but you can turn those on or off as the case may be by the slider switch under convection here. So if I have these turned on, these are always valid 2 to 6 hours beyond the issuance time. So 2 to 6 hours beyond the issuance time. So if you have this all the way over to the far left, you notice they are not there. And that's because they're technically not valid until the time that's shown here, which is 2055 Zulu. And so yes, it matches that 21Z is within this time frame from 2055 to 0055 Zulu. And that's why they're displayed at this particular point, but not when I set this particular departure advisor to 20Z. They're not valid. I know some applications out there put them up immediately, but that's technically not when they're valid, and I want to make sure that we show them at the proper time that they're valid. All right, so let's take a quick peek at all the different advisories and talk about the criteria that are used to essentially build these convective advisories called convective SIGMETs, and also a convective outlook, and we'll talk about center weather advisories in addition. Obviously convective SIGMETs, and they're also non-convective SIGMETs as well. So if you look at the layer selector, you're going to see under SIGMETs, I'm going to go ahead and select all of them for now. SIGMETs come in many different forms. There's a turbulent SIGMET, airframe icing, dust and sandstorms, volcanic ash. So all those are non-convective SIGMETs. Basically, these are dangerous areas of weather that are not related directly to convection. So turbulence would be things like clear air turbulence or mountain wave turbulence. Airframe icing would be, again, non-convective icing. Dust and sandstorms have nothing to do with any of that. Convection can actually produce dust and sandstorms, but it's mostly due to the lowering of the visibility that those are issued. And of course, volcanic ash are from volcanic eruptions, which have their own convective elements, so to speak, associated with it. Again, we're focused right now on things that are generating convection for convective SIGMETs. And there are also outlooks that go hand in hand. So these are issued by meteorologists at the Aviation Weather Center in Kansas City, Missouri. And their goal is to put a fence around areas of dangerous weather, specifically in this case convection. And you notice I didn't say thunderstorms, because lightning is not a requirement, and neither is heavy precipitation. It could be raining really heavy, and it may not necessarily get a convective SIGMET per se, but in the end, if it's a convective process that the forecaster believes is dangerous for pilots, for all aircraft, they will issue a convective SIGMET accordingly. And so convective SIGMETs are issued for actual areas of thunderstorms, even though they're technically a forecast valid for a 2-hour period. So if we pick any one of these, you'll notice this is issued at 1855 Zulu, valid through 2055 Zulu. So that's a 2-hour period. They're technically a forecast from that standpoint, but they won't issue these unless there's truly thunderstorms or convection that are happening at that particular time. So it's not like there's an area of weather that they're concerned about. There may not even be any clouds out there, yet they're not going to issue a convective SIGMET for something that's not active. So when we're looking at these convective SIGMETs, let's turn on the radar depiction for now. We're actually trying to only look at those areas that where the forecasters believe this would be a hazard to aviation. Now, a single cell or two out there, if it can be seen visibly from a distance and you're flying along, you're probably not going to see a convective SIGMET issued, although they can issue convective SIGMETs for single cells, especially if they end up being severe. A single severe supercell thunderstorm will likely get a convective SIGMET, and we'll talk about the criteria in just a bit. So the important thing to note is that you actually have to have areas of actual convection and thunderstorms happening before a convective SIGMET is issued. So this is more of a nowcast rather than a forecast. That's not true necessarily of graphical airmets or G-airmets, but it is true of most SIGMETs, and including convective SIGMETs. So in the end, when you look at non-convective SIGMETs for turbulence and icing, for instance, a lot of times they're not issued until pilots start reporting those conditions, and those are valid typically for a period of 4 hours. But for convective SIGMETs, they're issued typically at near the top of the hour, at 55 minutes past the hour. So most of these that you see here will have a 55-minute past the hour issuance time. Although that may not be the case all the time. If an area of weather develops pretty quickly, then you might find one or two of these might actually have something other than 55 minutes past the hour. But that's usually not the case. Essentially, there's one forecaster at the Aviation Weather Center who's responsible for issuing all these convective SIGMETs. And on a day like this, it's really, really busy for that forecaster because they are spending most of their time trying to put fences around areas of significant weather. And so you'll see again 1855, 55 minutes past the hour. And so they're not going to stick around for 2 hours. Typically what will happen is that another convective SIGMET will come along and replace it the next hour at 55 minutes, or they'll just let it drop immediately and end it essentially. It's not really canceled per se. They just don't put out another SIGMET. So as we know, as weather moves, so as we see weather moving from one place to the next, these convective SIGMETs will move along with that weather. But they don't necessarily drop a convective SIGMET, canceling it like they would non-convective SIGMETs for turbulence or icing when conditions are not showing those particular elements. So it's real important for you to understand that these are actual areas of weather and not really a forecast per se. So what are the general requirements for convective SIGMETs? Well, there are generally 4 criteria that are used. First of all, these typically are shown for an area of thunderstorms of at least 3,000 square miles or greater, a line of thunderstorms or convection, I shouldn't always say thunderstorms, but convection, that is at least 60 nautical miles long and is at least 40% of coverage on that line. The same with the area. The area has to be at least 3,000 square miles or greater, and coverage in that area has to be around 40% or more. Then the other criteria is embedded thunderstorms, and it doesn't matter the size. In that particular case, they're embedded, so you can't see them visually from the outside looking into the thunderstorm area. You really can't tell. Normally in those embedded thunderstorms, you're looking also for where are the areas where there's widespread lower IFR conditions or even marginal VFR conditions. When you have those kind of conditions coupled with thunderstorms, generally they're embedded. And then you also have the severe category. So anytime the National Weather Service Weather Forecast Offices issues a severe thunderstorm warning, in that particular case, not a watch, but a warning, then they'll typically put a convective SIGMET around that either area of severe thunderstorms, line of severe thunderstorms, or even a single cell severe thunderstorm will get a convective SIGMET in that particular situation. And so here's one. Let's take a look and see what this one says here. This is an isolated thunderstorm right here, and that's a convective SIGMET that's 1855 to 2055. So I don't see any that are special SIGMETs. In other words, they can issue at any time a special. They can go out at any time where they think that the weather is dangerous from that standpoint. I'm looking at all these and do not see any here. Let's go up to here and see if we can find any of those. Most of them that are, say, plugging along with current convection that has existed for a couple hours, you're not going to see these be special. In most of the cases, they're going to be well defined and be followed throughout the area. And so let's see if we have this area here. So nothing is showing up here. Let's go out west. Unusual to see some Southern California convection that gets a convective SIGMET, but there you go. So once again, 1855 Zulu. And like clockwork, at 1955 Zulu, they'll update these. And they'll let some of these drop that where the convection no longer exists, and they'll essentially establish a new convective SIGMET. And one of the things you also can notice here is that convective SIGMETs are issued by east, central, and west. And you'll see that in the actual text. So this says SIG-C, which means it's a convective SIGMET. I'm sorry, SIG-C means convective SIGMET, and here's 18C. That means this is the 18th convective SIGMET that was issued for the central region since 0Z. Let's look at what we have here. Wow, convective SIGMET 96E. That means there was 96 convective SIGMETs issued since 0Z in the eastern area. That's a lot. So the eastern part of the country has been really busy today with convective SIGMETs. Okay, so again, summary. Convective SIGMETs are issued when there are active areas of convection or thunderstorms, and lightning is not a criteria. They're issued for these areas that are 3,000 square miles or greater. 3,000 square miles is about 2/3 of the size of the state of Connecticut, so it's not really all that large, unless it's a single cell, and it could be smaller from that standpoint. But that wouldn't be an area of thunderstorms or an area of convection. They issue them for a line of convection, for embedded convection, and for severe convection. So those are the four criteria. They're issued at typically 55 minutes past the hour. They're valid for 2 hours, but again, they're typically replaced after an hour, or they let those drop. And in effect, they can issue a special at any time. The typical goal, though, is to wait for that area of weather to have persisted for at least 25 minutes before they will typically issue it. So usually in the period between 55 minutes after and somewhere around 20 or 25 minutes after, normally you won't see any specials issued. Again, they could do that, but it's usually somewhere around 25 minutes after the hour where they'll finally start to see some specials kind of pop up. And then again, at 55 minutes past the hour, they go through and reevaluate it. So the forecaster right now is preparing their convective SIGMETs for the next issuance in about 30 minutes from now. Okay, so that's the basic understanding of what are convective SIGMETs. Now, along with convective SIGMETs are one of my favorite products that are issued, probably the least used, and they're really hard to find at least at the Aviation Weather Center. They use a static image to actually define them. They're not shown on any of the maps. That are convective outlooks. Convective outlooks issued also by the same forecaster. Now, if you're looking at 20Z, those convective outlooks are not valid. You'll see that if I move this departure advisor, these areas here pop up. So this basically tells you that these yellow polygons, and you can see here, these are actually separated by east, central, and west. That line down here is the demarcation between east and central. And they're valid for a period of from 2 to 6 hours from the time they were issued. So this was issued at 1855 Zulu, and it's essentially valid from 2055 to 0155 Zulu. So 2 to 6 hour period. And they tell you that these are areas that they feel will have convection that meets convective SIGMET criteria. Now, there may not be any convective SIGMETs in those areas at the time they're issued, but the goal is that they feel there's going to be thunderstorms or convection that do develop that meet that criteria in these areas. So this is a good hint when you're just about ready to get into the cockpit and depart. Take a look at this. Now, this is a very active convective weather day over much of the U.S. So it's not necessarily going to be the norm, but in general, these areas pop up, and let's say you were making a flight from, let's say, Charlotte to Memphis or something like that, Memphis, Tennessee. In those particular cases, if there was a convective outlook in that particular area but no convective SIGMETs, that tells me in that 2 to 6 hour window I should expect thunderstorms to move into that area or develop within that area that meet those criteria. Now, the criteria seems to be kind of arbitrary, I think, in some cases, because what we want to understand is that a single cell out there, if you're watching a cell from the distance, you're flying toward it, you just don't fly in it or under it, you go around it. So it's very quick to make that little 5 degree, 10 degree vector around that particular cell, and you're by it. You don't spend a lot of extra fuel. There's no lot of worries about getting yourself into trouble. It's when you pull together a bunch of those cells into an area that's large enough that you actually have to make a significant deviation around those, or a line of convection. Once again, you could maybe find a hole in that line, but you probably want to go all the way around that. Again, you have to take extra fuel to go around that, or you start consuming extra fuel. That's why they put these convective SIGMETs out there. It's mainly to understand that this is a hazardous area you're probably going to have to go around, and they try to make them with as few points. The goal is to actually have a triangle, 3 points, but in reality sometimes you need 4 or 5 points associated with these. But it's mainly so that it can warn you that you're going to need some extra fuel to get around this area if your flight goes through that convective SIGMET. Now, it's not illegal to fly through a convective SIGMET, and I have flown through many convective SIGMETs over the years with plenty margins, because again, that area of thunderstorms or area of convection might have significant holes in it. They're trying again put a fence around the area they think is the most significant region, but there will be areas that are soft or don't necessarily have any significant convection, or maybe convection is in a dissipating state at that time, and which you're coming to that convective SIGMET where the thunderstorms or convection are essentially dissipating. So all that plays into this. So make sure that you understand that these convective SIGMETs, and even something as simple as embedded convection, are something that you don't want to tangle with, because you can't visually see that. Now, if you have onboard radar, you might be able to pick that out, but this is to alert you that that particular area of embedded convection is going to be difficult. And it could be just a small, really small area, but they'll put a convective SIGMET around that region if they think it's embedded. And of course, severe convection demands a much wider berth around it, because that usually generates some extremely strong low-level winds, strong surface winds, you got outflow and downdrafts, you've got the possibility of hail, tornadic aspects to it. So you really want to keep your distance. I usually tell folks that that 20-mile rule that the FAA tells you need to follow around thunderstorms, stay 20 miles away. I think that's pretty naive when you're dealing with severe convection. Personally, if that particular severe area is headed toward me, I'm going to give it at least a 50-mile berth, because we've seen in many cases some of those outflow boundaries and some turbulence extend much beyond that 20-mile area. So ultimately, with severe convection, I'm going to give it at least a 50-mile distance between that and the main core of the storm itself. To me, that's the best approach here from a severe convection. So that's why it's important when you're looking at the convective SIGMETs, look at the text. So it's not just a matter of looking at the area, but read the text. An area of thunderstorms moving from 190 at 15 knots, tops above flight level 450. They don't tell you about what the actual tops are. Once they reach 45,000 feet, flight level 450, anything that's higher than that, they don't provide any details. If it's lower than that, if the tops are lower, they'll typically tell you what the lower tops are. In this case, tops to flight level 380, but an area of thunderstorms. If it's a severe area of thunderstorms, for instance, it will tell you that as well. Let's see, here's another one. Area of severe thunderstorms, 50 knots, tops above flight level 450, and they'll talk about hail to 2 inches in diameter, wind gusts to 50 knots possible. And I also recommend looking at the Storm Prediction Center and also the local weather forecast offices for the details of what's going on with those severe thunderstorms. All right, so that gives you a pretty good idea about what's happening with convective SIGMETs. And there's one more topic I want to talk about, and that's center weather advisories. You'll see center weather advisories. Very similar to SIGMETs in that there's an airframe icing, turbulence, IFR conditions, convection. There's even other, and other just kind of is a catch-all, because unfortunately well, let's say the convective SIGMETs have very rigorous syntax in what they have to say or don't say, whereas the center weather service units with center weather advisories have a lot more looser regulations or rules to follow, and sometimes they don't code things exactly the way they should. So some things like heavy precipitation doesn't fall into any of these, or in some cases there'll be freezing rain or freezing drizzle or something like that that will not find its way into one of these specific topics here, even though there should be icing. Ultimately, that may end up showing up as other. But from a convective standpoint, we have essentially center weather advisories shown here for thunderstorms. So let's look at this one here. This will basically tell you again what the details are if you click on it. So this is a center weather advisory from the Fort Worth Air Route Traffic Control Center, the center weather service unit located there. Typically these are issued, they're issued for no more than typically 2 hours of time. So they're really short, they're kind of that front lines, if you will. And they don't have specific criteria per se. You don't have to meet certain national SIGMET criteria. Instead, a lot of times even if you get some widely developing area of towering cumulus that start to become to the point where aircraft have to deviate around those, they will issue a center weather advisory for those. So they're really complementary to these convective SIGMETs. So this is an area of rain showers, widely scattered rain and thunderstorms, moving from a direction of 150 at 15 knots, and here's the tops. And so they'll be issued, and again, there are really more of a in-flight thing than really a pre-flight thing, to be honest, because they're typically going to be responding very quickly to developing weather. And they don't do this in isolation. So when there are interesting weather events, they try to coordinate that with the Aviation Weather Center. So there's a bat phone per se, where they pick it up and they call and they talk to each other. They don't try to, at times they try to make sure that they're not talking about the same thing, but that does happen from time to time, as you can see this overlap. But in many cases where there are areas of weather that are kind of isolated or maybe affecting certain high impact airports or regions where lots of aircraft are moving through, they may not necessarily issue a convective SIGMET for that area, but they may issue one of these thunderstorms center weather advisories. So again, they should be complementary in that particular case. Okay, so that's overall a good picture of the convective weather advisories that are issued by the Aviation Weather Center and the Center Weather Service units for the convection you'll see. And these are, again, issued all year round, whether or not you'll be in the summertime or wintertime. Obviously, most of the time we see these are in the summertime or even spring and fall. But if you fly in the southern part of the United States, not unusual to see convective SIGMETs in the wintertime in Florida or along the Gulf Coast states or even in the southeast. So that completes episode 11 of Easy Weather Chat. My name is Dr. Scott Dennstaedt, and as always, enjoy the simplicity of EZWxBrief.